Okay, how about 5.6 problems? I assigned a lot here. And let's see, some of the problems early on are not that bad. And the latter problems with variable coefficients, okay, they're going to be more challenging. Okay, how about 2 and 4? Those are even numbered. Okay. They look okay to me, so let's select something similar. Number 3, the one right in between, so let's go ahead with that. Okay, so right. Let's do some work on 5.6. And problem 3. Okay, what is problem 3? Y double prime minus 2y prime plus 5y is equal to exponential of t power. And we have to find out a particular solution, isn't it? Yes, but the general solutions of homogeneous equation are not given here, so it looks like you have to find that one first. Okay, alright, let's go ahead. Let's look at the characteristic polynomial s squared minus 2s plus 5 and set it equal to 0. Oh, by the way, if you're wondering where this thing is coming into play, there are many ways to do it. One is Laplace transform. Another is to set y equals to e to the s times t. And then calculate y prime. Then it is s e to the s t. Y double prime is another s squared e to the s times t. So if you plug everything in there, what do you get? Y double prime, so s squared e to the s t minus 2 s e to the s t plus 5 exponential of st, and we are looking for homogeneous equations, so this is equal to 0, which means we can remove all these exponentials out, and we get the characteristic equation like this. But of course, experienced students will go directly over to the characteristic equation. Let's solve this, and this is equivalent to s is equal to, this is even number, so let's go directly to this. 1 plus or minus square root of 1 squared minus ac. So what do you get? 1 plus or minus square root of negative 4, isn't it? Or square root of 4i, or equivalent speaking, plus or minus 2i. So we have these characteristic values. Oh, excuse me. S is equal to exponential of, come on. Let's do this again. S is equal to y1 of t is equals to exponential of 1t plus 2it y2 of t is exponential of 1 minus 2i t. There you go, those are solutions of homogeneous equations. And then the general solution will be yh of t will be c1 and then this complex exponential plus c2, this complex exponential. Oops. No, this should be minus. Sign change there. And let's see, this is homogeneous. But then again, if you don't like the complex exponentials, in that case you can change into sine and cosines. If you want to, that is. You can keep it as complex exponential if you prefer. I prefer. You can write like this as well. This one over here and that one down here, they are equivalent. These are homogeneous. Okay, alright, we got those. And now next step is to find out particular solution. Okay. Let's apply variation of parameter. Step 2. And you want u1 y1 plus u2 y2, which is u1 t times this one plus u2 that's the kind of solution that you're looking for. Also, you want an additional restriction here. u1 prime y1 plus u2 prime y. I keep pressing the wrong key, excuse me. Okay, another restriction here, and let's highlight it in some different color. Okay, let us go ahead. Let's calculate the derivative and then do some work. We have product rule and so on, so this will turn out to be ugly. Maybe, shall we go ahead with complex exponentials right away? In that case, we have some complex multiplication. Oh, never mind, let's just stick to this. So what's the derivative here? Derivative is, okay, product rule here, u1 prime y1 plus u2 u1 y prime plus u2 prime y2 plus u2 y2 prime, isn't it? We just use the product rule for this one. We have it here, and that one for this one, let's check if I have it correctly here. The derivative of the first function, second function first, and the derivative of the second function should have been y1 here. And the same thing, okay, alright. Now, u1 prime y1 is over here. And then u2 prime y2 is over here. Add up to 0. So as usual, you're gonna get u1 y1 prime plus u2 y2 prime. That's gonna be your derivative, first derivative. Okay, how about the second derivative? This time you're not gonna get so lucky, so you have to do product rule for these two, both of them. u1 prime y1 double prime y1 prime plus u1 y1 double prime plus u2 prime y2 prime plus u2 y2 double prime. So we'll have to plug all those into this original equation. Okay, let's go ahead and do that. Okay, so here's our equation here. And then for this one, I have to plug in this thing. And for this one, I have to plug in this part. And then for this one, it's gonna be this. That equals e to the t power. Okay, how do we simplify that? We'll have to use the fact that y1 and y2 satisfies a homogeneity equation that this left-hand side is equal to 0 if you replace this one as 0. So we're gonna have to use that one. Let's see. How do I get that? Get these u1s here. And then you get y1 double prime. And then 2y1 prime. And then, oh, excuse me, I forgot parentheses here. And then 5y1. So, okay, what did you just do? This one we got. And this one we just got. And this one. Next, how about u2? Here we go. y2 double prime plus 2y2 plus 5y2. By the way, I forgot the derivative here. And it's this one. And this one, which I'm highlighting in red. So these red, these blue, they're becoming 0. And what's left will be only the black part. u1 prime y1 prime plus u2 prime y2 prime is equals to e to the t power. And this is 0 because y1 is the solution of homogeneous equation. That 2 is 0, so you're going to get only this part. Okay, this is the equation we started off with. And then this is the one I just got. And solving this system of linear equations, y1, y2 are, where are those? y1 and y2 are like this. This is y1, that's y2. And then y1 prime, y2 prime, you have to do some derivative computation, but if you put those in and then solve the system of linear equation, you're going to get u1 prime and u2 prime. That's the idea.